Hi guys, in this video I'll take you through mechanical properties of engineering materials. Before we go through the video, another important action is please subscribe to my channel Learning Directory to get updates on my channel. Let's start the discussion. First of all, how do we define property of a substance? So, property is nothing but behavior or character of a substance when it is subjected to different conditions. When it comes to material, they are characterized by their properties such as hard, ductile, and heavy. Conversely, material can be soft, brittle, and light. In detailed view, how do we define mechanical properties of engineering material? Let's see that. The properties that describes the behavior of the material under the action of external force. This is the definition of mechanical properties of engineering materials. That means when load is applied, the object will undergo multiple changes such as change in shape and size. While these changes are happening, how does the material behave or how it reacts to is measured by mechanical properties. Some important mechanical properties are listed here. They are strength, elasticity, plasticity, stiffness, also called as rigidity, resilience, toughness, malleability, ductility, brittleness, and hardness. Let us see each of these in details. The first mechanical property is strength. It is defined as ability of a material to resist without rupture while external force is causing various types of stresses. That means when external load is applied, it can cause various types of stresses. While stresses are acting, metal has to resist these stresses without rupture. The ability of the resistance is measured by a parameter called strength. It is measured by different quantities such as tensile strength, compressive strength, and shear strength. Example, when tensile load is applied, the component will experience tensile stress. The ability to resist this tensile stress is measured by tensile strength. Similarly, compressive strength and shear strength can be defined. Second property is elasticity. Elasticity is the ability of a material to retain its original shape and size after deformation when external load is removed. So, when load is applied to the component, it will deform and component size and shape will change. These changes varies based on material. When component is unloaded, all material will not regain its original shape and size. The ability of the material that will regain its shape and size is defined by elasticity. When we see stress strain diagram, the material will have so-called elastic limit. All the materials are elastic in nature till elastic point. Within this elastic limit, material will undergo small deformation. During this elastic deformation, atoms of metal are displaced from its original position. Hence, the component is deformed. When the component is unloaded, atoms will return to its original shape and position. Hence, the material will regain its original shape. Next property is plasticity. It is the ability of material to retain the deformation produced under the load on permanent basis. When we load the component, it starts deformation. As I told earlier, when it is unloaded, it will regain its original shape and size if it is within elastic limit. Within elastic limit, stress strain curve is linear. After elastic limit, metal will go to plastic deformation where material cannot regain its original shape completely. During plastic deformation, atoms displaced from its original position will not return to its original position. Hence, the material shape and size cannot be regained. The ability of a material to deform extensively in this plastic range without rupture is also one of the important property or parameter. Now let us see the differences between elasticity and plasticity. The first point is elasticity is the ability to regain the original shape after deformation, whereas plasticity is ability to retain the deformation. Here just observe the words regain and retain. In elasticity, the ability to regain original shape after deformation, but in plasticity, it will retain the deformation. Second one is elastic deformation is very small, but the plastic deformation is relatively more. A third point, during the elastic region, atoms will return to its original shape after deformation, but in plastic region, atoms will not return to its original position. Last one is stress strain diagram is linear in elastic region, but it is non-linear in plastic region. Next property is stiffness, also called as rigidity. This is the ability of the material to resist the deformation under the action of external load. All the metals will undergo deformation when external load is applied, but the deformation magnitude can be more or less based on the type of material. When small load is applied initially, then it will not have any deformation. As the load magnitude is increased, it starts deformation. The resistance offered by the material till its deformation starts is measured by stiffness, and stiffness is measured by a modulus of elasticity or Young's modulus. Next measurable property is resilience. It is defined as ability of the material to absorb energy when metal is deformed elastically and release that energy when component is unloaded. Resilient material will absorb energy within the plastic limit. Sorry, it's not plastic limit, it is elastic limit without permanent deformation. This property is important while selecting the material for components such as springs. If you see spring, when load is applied, then spring will absorb the energy, and when load is released, it will come back to its original shape by releasing that energy. So resilience is measured by a modulus of resilience. Modulus of resilience is calculated as strain energy per unit volume. As shown in image, it is represented by an area under the stress strain curve within elastic limit. Similarly, toughness. It is the ability of material to absorb energy till fracture takes place. It is important factor for machine components where it has to withstand from impact loading. Tough material will have the ability to bend, twist, or stretch before it takes place fracture. It is measured by a quantity called modulus of toughness. It is nothing but total area under the stress strain curve till its failure as shown in image. Now let us see the difference between resilience and toughness. The first one is resilience is the ability of the material to absorb energy within elastic limit, but toughness is the ability of material to absorb energy till its failure, that is including elastic and plastic region. And the second one is resilience is measured under area of stress strain curve within elastic zone, but toughness is measured as area under the stress strain curve in both elastic and plastic region. And the last one is resilience is considered while selecting the material for component such as springs, but toughness is important consideration in components subjected to bends, twist, and stretch or impact loading. Next metal property is malleability. It is the ability of the material to deform to the greater extent before sign of crack when the component is subjected to compressive load. When the component is subjected to compressive load, it will start deforming. As load increases, the deformation will also be increased. So the ability of the material to deform to the greater extent before crack forms is measured by parameter called malleability. Malleable metal can be rolled, forged, or extruded as the operation happens with application of compressive loads. This malleability increases with temperature because when the temperature is increased, it becomes more ductile and it can be deformed easily to the larger extent. Similarly, the next property is ductility. It is the ability of material to deform to the greater extent before sign of crack when tensile load is applied. Malleability is for compression load and ductility is for tension load. Ductile means stress strain curve is linear. Ductile material can be formed, drawn, or bent as the operation process takes place while tension load is applied. Ductility decreases when the temperature is increased because when temperature is increased, ductile behavior of material will increase so that for a smaller load also deformation will be more comparatively and this crack formation will be quick. Next property is brittleness. Brittleness is the property of material that shows negligible plastic deformation before fracture takes place. In comparison with ductile material will undergo deformation before fracture, but a brittle material will not undergo any plastic deformation before fracture. The last mechanical property is hardness. It is defined as resistance of a material to penetration. That means how much resistance is offered by a material during other component is penetrating. It is important property while selecting the material for parts which rub on one another such as rail and wheel or cam and follower etc. That's all guys on mechanical properties of engineering materials. Please subscribe to my channel Learning Directory for more updates. Thank you.